welcome everyone. In this chapter, we will see the introduction to dynamic routing. So, as of now, we have gone through static routing and we need to understand why dynamic routing first. So, let's get started. So, first of all, we need to understand that why this dynamic routing is needed. Of course, yes, there is a specific requirement for the same. So let's look into the same, that what is the disadvantage and advantage of the static routing, so that will be clear why exactly the dynamic routing is needed. So the very basic point, this all the topics, I mean the points is completely on the basis of static routing itself. So what happens if you are using the static routing, what will be the advantage and what will be the disadvantage? So let's try and understand here. So first of all, your dynamic routing, of course, your dynamic routing has the capability for dynamic algorithm to perform the dynamic operations. When it comes to static, of course, a static is all about, it is one of the manually configured routing where it is very secure because there is no routing update exchange between the routers. It is very secure and also it is very reliable because the administrative distance for static routing is 1. Faster, of course, yes, it is very fast as compared to dynamic routing. Your static routing is very fast because the moment administrator is going to configure the static routing, the syntax, immediately it will install that complete routes into the routing table so that it is very faster. Make sure here the routers doesn't need to exchange the routing informations because it is completely manual. Make sure there is no bandwidth wastage as well, because normally when the routers are exchanging the routing updates or maybe routing packets, so definitely there is a bandwidth wastage will be. But in terms of a static routing, there is no hello, no routing information update exchange between the routers, so of course no wastage of your bandwidth as well. These are couple of advantages as you can see here. But when it comes to the major use cases, so static routing can be used for, of course, very small kind of organizations in very small scenario. When it comes to larger network and larger, scenarios, of course, you need to go through the dynamic routing only because the administrative work will be so much in terms of static routing. Talking about the disadvantage now, very common. Of course, as we have discussed in static routing, of course, there is no automatic update. Make sure in static routing there is no automatic update. Means if any network is added or maybe any router is going down or coming up, there is no automatic update for the same. Manually you need to add or maybe you need to remove that. Make sure while the configuration of static routing itself, you need to have the destination network ID for the configurations. If you remember the syntax for static routing, it was like IP route and then destination network ID, destination subnet mask, and then next hop IP address or maybe exit interface. But you need to know the destination network, then only you can configure the static routing. And of course, if you are having, let's say, multiple router, let's say 10 routers you have, and you want to configure the static routing in all, so you must be knowing the destination of all 10 routers LAN interfaces to configure. Make sure administrative work is more, of course, yes, because you need to manually add or remove your networks from the same static routing. It can be used for your small networks mostly, not used for your bigger network or maybe medium or large size of networks because of there is no automatic update, and these are the couple of disadvantages that you have. So make sure static routing is used still in some of the scenario, but when it comes to dynamic routing, it has its own place because it is having the dynamic nature of update and dynamic nature of algorithm as well. So now we'll discuss about the dynamic routing features and the type of dynamic routing as well. So I hope this is clear to you that why dynamic routing. These are the major concerns. So far, moving ahead. So So when it comes to your dynamic routing, of course you need to understand the functions of your dynamic routing itself. Of course there is major points that you need to remember about the dynamic routings. So let's get started. So the very first thing, make sure this is a very good concept of your routing in the nature, because there is no need to know the destination network for the configuration. That's the very first thing. You doesn't need to know the destination network. How dynamic routing protocol works? It's all about, let's say this is a router connected with, let's say, some other router here, and this is, let's say, consider this is a LAN interfaces. So normally when you are configuring the dynamic routing protocol in these routers, what happens? Normally these routers will say, hey, I have this all the connected networks to my serial 0 and my ethernet 0. You take my update the network, and similarly this router will say, I have this serial and this ethernet interface, you take my update, routing updates. So routers are going to advertise the self network itself to the neighbor routers. This is how your dynamic routing works. Okay, so you doesn't need to know the destination network for the configuration in in dynamic routing. Make sure that's very important. Moving ahead, make sure in dynamic routing the routers discover the neighbors, exchange the routing informations, and build the routing tables automatically, because it has the dynamic algorithm. Using that, it will do this all the operations here. Make sure the routers which is running with dynamic routing protocols can choose the best path if you have multiple available path. For example, let's say the router's connectivity is like this. Let's say router's connectivity is like this. Consider these routers are connected like this. Let's say you have some of the network here. Let's say you consider this is my source network and this is my destination network. So normally your router 1 can reach to, let's say, router 5 via any of the path here. For example, you have path 1, path 2 and path 3. Multiple path you have. So now the routing protocols, whether you configure any routing protocols, that will help you to select the best path out of this available path. Any one path can be the best path, or maybe two path can be the best path. In case if multiple path is best path, routers will perform the load balancing. They will perform the load balancing in the sense, first packet via first path, second packet via second path, third packet via first path, fourth packet via next path. So it's like one by one packet, another path, one by one, it will take the load balancing. But right now you see, choosing the best path in available path, that's very important. Consider you configure any routing protocol, and let's say this is one of the best path for you. Let's say this is one of the best path for you. So if it is the best path, of course routers will forward the complete information via this only. But what happens if it is going down? If it fails, routers will go ahead and select the second best path, and it will forward the data out of this available path itself. So that's what the complete nature of your dynamic routing itself. That's very important, you need to remember. So that's what the next line it is talking about, that whenever best path is going down, finding the new best path and forwarding the data through that best path is the job of your dynamic routing. Moving ahead, this is very important. In this dynamic routing, always the topology change can take dynamically, automatically. It's all about if you are adding any other routers, or maybe you are removing any other routers. And when it comes to static routing, manually you need to add or remove the routes. But when it comes to dynamic routing protocols, of course, any network is going down or maybe coming up, if it is running with a routing protocol, that complete informations will be adding and removing automatically whenever router's interface is going down and coming up. So the topology change is dynamically, automatically. You no need to change manually here. That's very important. Couple of more advantages when it comes to your dynamic routing protocols. See, make sure when you are configuring the dynamic routing, for example, Let's say you have two routers here. So normally, as I said, if you are working with the static routing protocols and if you want to configure the routing between these two routers, let's say R1 and R2. So if you consider this as source and this as destination, you must know the destination network for configuration. But when it comes to dynamic protocols, of course, right now you just need to advertise your directly connected network informations for configuration here. It's like once you configure routing protocol in this router, you will say this is my network and this is my connected network. This is connected to Ethernet and this is connected to my serial. This network you send to neighbor router. Similarly, this router S1 and let's say this is Ethernet. This network you will send to neighbor router. It's like its own directly connected network is needed for configurations and routers will advertise the same network itself to the neighbor routers so that neighbor routers can learn the same and they can maintain the routing protocol updates. That is nothing but your they will build the routing table. Fine. Automatic updates, of course, yes, when there is a topology change, automatic updates will be there. Make sure administrative work is reduced. As we discussed, in case of a static routing, you can use it for a small network. But whenever you are going for larger network, it becomes really difficult and administrative work is so heavy, tedious task. That's where your dynamic routing protocol help you to reduce the administrative workload, and of course you can use it for more scalable like medium or large size of network itself. So this is what the advantage of using your routing protocols. Now, we need to understand that the dynamic routing itself is having the multiple categories. So first of all, we need to understand, let's say you can have the routing protocols use cases as, let's say, a protocol which can be used within the organizations, a protocols which is used within the organization itself, and second thing is a protocol which is used between the organizations, so you have two things to remember. Routing protocols can be used to route the informations within the information if you have multiple routers, or between the routers, between the organizations also it can be used. So this is basically categorized into two, which is IGP, interior gateway protocol, EGP, exterior gateway protocol. So dynamic routing protocol has two category. One is IGP, interior gateway routing protocol, and then you have EGP, exterior gateway protocols. So the difference between this are very common things. It's all about this will be used within the organizations. If you have multiple routers to connect, you can. And exterior, this is basically EGP, which is basically used between the organization itself. Make sure between two organizations you can use it. Now make sure whenever you are calling the organizations, normally we can call, but in terms of routing protocols we call it as AS, autonomous system. Autonomous system is equal to one organizations. Okay, so what is autonomous system? I will discuss one more time in our coming lecture, but make sure whenever we discuss about two different organizations, you can call it as two different autonomous system, two different companies. Fine. So coming to our major topic, this is within the organizations and this is between the autonomous system. Make sure when it comes to your IGP, it is divided into two protocols. You have the distance vector protocol and you have link state protocol here. Where in distance vector routing protocols, you have two major protocol, which is RIP version 1 and IGRP. RIP version 1 and IGRP. What is this RIP version 1 and IGRP? Make sure this both are under distance vector routing protocol, and RIP version 1 and IGRP both are not in used in production. It is not at all in used in productions. RIP stand for routing information protocol. IGRP stand for interior gateway routing protocol. interior gateway routing protocols. Now, next we have in link state you have one protocol which is known as OSPF, and then you have the IS. OSPF, open shortest path first. OSPF is a link state protocol which is open shortest path first. Link state routing protocol has one more category which is IS, intermediate system to intermediate system. This is intermediate system to intermediate systems. Make sure this RIP version 1 and IGRP both has some problem. That's the main reason not used in production. You know what happens? Later on, developers has done the enhancement on this, and they said we are going to upgrade and made it as advanced distance vector protocol. Advanced distance vector protocol. When it comes to advanced distance vector protocol, it is all about RIP version 2 and EIGRP. RIP version 2 and EIGRP. EIGRP stand for Enhanced Interior Gateway Routing Protocols. Now, make sure this all the protocols which we discussed here, this all the protocols used within the organizations. Means within the organizations, if you have multiple routers, you can have the routing exchange between them. But what happens if I am connecting two different autonomous systems, two different organizations? So of course you need to go through one of the protocol which is known as path vector protocol, and the protocol is BGP, border gateway protocol. Border gateway protocol is the major one. So this is the classifications of your dynamic routing protocols. Of course, we need to understand the difference between your IGP and EGP. So this is what you have. See, as we discussed, IGP stands for your interior gateway routing protocols, which is basically used to route the informations within the autonomous system, means within the organizations. EGP, exterior gateway routing protocols, which is basically used between different autonomous systems, different organizations. And the protocols which is in interior gateway protocol is IGRP, EIGRP, ISIS, OSPF, RIP, all the protocols will be. And in EGP there is only one protocol which is considered as border gateway protocol. Border gateway protocol. So this is a difference, quick difference between these two that we have. So next we will talk about classful and classless routing protocols as well. Right now I will not discuss about this. In next I will talk about what exactly the difference between classless and classful routing protocols in detail. But right now I just wanted to introduce that what exactly the difference between classless and classful. In simple term, as we discuss a very common scenario that if you have, let's say, a router here connected to, let's say, some other router, and let's say we are going to configure dynamic routing protocol in this, let's say RIP. So normally when you configure RIP, of course RIP will advertise the update here, RIP will advertise the update here. Now the point is, in this particular update, what kind of information it is going to contain? That's very important. So make sure what happens in some of the routing protocols, they will just carry the network ID. They will just carry the network ID in some of the routing protocols. And in some of the routing protocols, you will find they will carry the network ID along with the subnet mask. Along with the subnet mask. So when they carry just network ID, they considered as classful. When they carry network ID and subnet mask both, they considered as classless. Read this. Very simple. Read this. Classful routing protocols do not send the subnet mask in the routing updates. That's very important. Your classful routing protocols do not send the subnet mask in the routing updates. Means they doesn't support this subnetting itself. Which are the protocols like RIP version 1 and IGRP. These are some of the old protocols which not support subnetting. That's where they are outdated and not in used. When it comes to classless, they carry the subnet mask in the routing updates. It's all about network ID and subnet mask both. They support subnetting in simple term, and the protocols are except RIP version 1 and IGRP, all other protocols are classless routing protocols. All other protocols are classless routing protocols we have. So make sure in simple term, classful and classless. Classless carries the subnet mask in the routing information. Classful do not carry the subnet mask in routing information. So which is best? Always classless is going to be the best protocol because it carries the exact network ID and exact subnet mask as well. That's very important. Moving ahead. This is up for this guys. Thank you so much for this. We will see you in the next lecture with the next routing protocol itself. Thank you.